Hello, welcome to our podcast. Floor is yours.
Oh, it's always a pleasure, Mustafa. You know how great this whole data community is that we've created around the LinkedIn and YouTube and so on. So lots of good information, knowledge, just brilliant. And it's a pleasure to be on your podcast. Looking forward to actually having a conversation with you here. So I'm Val Goldin. I'm the co-founder and CEO of a company called IOblend. We've created a data integration product around Apache Spark, and it allows data developers, data engineers to integrate data from pretty much any data source with any other end system very easily. So minimizes the number of days you spend developing data pipelines, testing, implementing, and running. So that's kind of essentially what we do in a nutshell.
Okay. Why don't you little bit tell us about yourself as well, your experiences, your past, because nowadays a lot of technical people are coming towards uh, business as well.
Yeah, no, it's a very interesting sort of background. Now, my original background is aviation, so it didn't directly deal with the data engineering and systems kind of concepts, but more was on around analytics and how do we use data to create better products, better services, optimize the airline, the operations, safety of it, yeah, maintenance, and so on. So I used to work for a company called EasyJet, which is a low-cost airline, and there was a lot of data sitting in different silos, but it was very hard to aggregate it. So we had subject matter experts, but we didn't really have a cross-company integration of that data and analytics on a grander scale. So every data project, every kind of initiative took months or years to implement. It's always painful, always manual. So the genesis of our solution basically came from that time because we felt the pain. We knew how difficult it was. Tried all sorts of different tools. Back in the day, real-time data didn't even really exist, which was about 10, 15 years ago. And sort of we met my business partner there, who used to be an architect at EasyJet as well, and sort of came up with this solution that, look, there's got to be a better way to do data integration. Because if we solve this problem, right, the businesses can get on and start working with the data rather than fighting to get the data to where they need, right? So that was kind of the premise of it. Well, what can we do around that? So my obviously my CTO is the genius, the technical brain behind it all. So he said, look, there's a new technology, which was back in 2015, 16, when it just started, called Apache Spark. And that was very interesting. So we started experimenting with it, playing around. And it's not an easiest technology to work with unless you're a very experienced data engineer. So, but it's very promising in terms of power, compute, scalability, ease of data management, and so on. So the idea was, well, can we take this technology and abstract all the complexity of working with Spark and just let the developers focus on the core that they need to do for the business, as in transformation logic, any kind of stored procedures, right? But abstract all the additional functionality that they have to build in each and every data pipeline, such as, schema management, schema drifts. You need to put data lineage, all the metadata around it, manage it all, right? Capture changes in the data, capture when the data starts drifting, when the schema starts drifting, and they have to put it all in, right? If they're doing real-time streaming data, then you have to also code around the logic. What if the system goes down? How do I aggregate streaming data with my historical data? Right? All of these features take time and expertise to do properly and then manage afterwards, right? So the logic was, look, we got to abstract that engineering layer away from manual work and just let the businesses focus on the core that they're good at, which is subject matter experts, right? What do I do with my data? How do I get value out of this data? without constantly questioning, how do I get it? Is it good quality? Can I trust it? And so on. So that's kind of what we started. And we've built a software around that that abstracts all this Spark complexity and allows you to just literally use SQL or Python to do the business logic or integrate stored procedures, even inject GenAI modules if you need to. So that's kind of where we are now. Use cases around, funny enough, it's very varied, right? I thought we'd be starting with some kind of like airlines business, the core to kind of our expertise. But no, we started with manufacturing because in the manufacturing company was struggling to get real-time data from their factories, and they wanted to move to that. So they experimented with Spark. They tried out the technologies. It just sort of wasn't working for them. It took a long time to implement. So they were stuck with a batch job once a week, and they were sending CSV files into the head office, and then they would transform it, clean it. But the issue was they didn't know what may have happened at the factories within the same day period. So you could have machinery stoppages or shortages of raw materials, labor issues that they wouldn't know until say 2, 3, 4 days into the process. So they couldn't properly forecast. Do we need to send more engineers there? Do we need to order more raw materials and so on? By moving to real-time analytics using our solution, they now could see in real time what was happening at the plants, and they had 17 different factories. So now they could start putting predictive analytics on top of it, right? Oh, this machine is doing 10,000 hours. It's designed to run for 15,000 hours. We need to send out an engineer to do the inspection and maintenance of it before we need to shut it down. So you start scaling it out across all the plants in different areas, raw materials, labor shortages, and so on. And now you're getting 7-figure annual saving from just preventing the disruption to your operations. So now there's a value to business, right? Rather than trying to get this data all the time, manage it and process it, the data is flowing automatically, and they're making decisions around the business. And that's the whole goal of our kind of solution. And then our use case is scaled out all over the places, right? I mean, we do ERP, CRM integrations, synchronizing various systems across businesses, different even geographies. We do real-time IoT, like sensor streaming data, processing that. So still hoping for an aviation use case, but at the moment we're sort of in every industry but aviation.
Okay, that is where you started. So before we go into technicalities, right? As you mentioned, you are an integration tool, right? When you say integration tool, you are also an ETL tool, right? Because integration normally restrict the tool to pull from source and throw into target. That's it. Nothing more than that. But ETL do a lot of stuff that it do all business transformations XYZ. It will give you a freedom of do all kind of things. But integration is only pull and push, just like Kafka, just like ADF, all those kind of stuff. So which zone you are in?
Yeah, no, you're absolutely right. I mean, and this is the confusing area around the terms that we have in data, right? We've got ELT, we've got ETL, we've got reverse ETL, right? And then we have this umbrella term data integration, which could mean anything and nothing. So the way you described it, I would say we're probably in the traditional ETL extract, transform, load, right? Then you want to massage it, right? You want to clean it. You want to make sure the data is in the shape that you can consume, and then allow the users to really spend little time post-processing it. Now, we can do that as well, which is why I'm hesitating to say that we're pure ETL, because think of it as a Swiss Army knife of tools, right? If you need to do ELT, you can. If you want to do ETL, you can. If you want to do reverse ETL, that does it too, right? Which is depending on the use case, right? Because we have use cases where data, for instance, coming out of sensors.
Hmm.
And sensor data could be patchy. Sometimes sensor goes down, sends false readings, and you need to essentially clean that data before it gets into the analytics, right? Otherwise, a human will spend a lot of time processing that data. And if you got hundreds of sensors, all sending information at different time frames, it's a nightmare job to clean it afterwards, right? So in this case, we use ETL because we have rules around what qualifies as quality data. And if the sensors go down, our system goes automatically, regresses, picks up the data from the moment when it went down, recomputes the totals going forward, right?
Yeah.
So that's that. But we also have cases where people just chuck in the data, sort of lift and shift, put it into, say, Snowflake, and then they work the magic there. So that's why I'm kind of trying to say we're data integrator, because that's sort of like an umbrella term for what it is that you can do rather than, oh no, we're just that.
Okay.
So, but
Okay.
I'll leave you to be the judge of it.
I will ask one more technical question. Right? When we say ETL and ELT, right? So yeah, there are different terms used differently, but very technically, what is different between ETL and ELT? When you run ETL, it use sources processing engine to transform in the memory and throw it. When ELT comes, ELT pull one to one, put it in your own memory, and then transform it through. So you are ELT or ETL.
Ours pulls up, then applies the say the management governance
Mm-mm.
policies around that, and you can do transformations while the data is in motion. So by the time you deposit it into the destination, it could be a usable data already. And
Okay.
it not only that, we also maintain the assets, so the tables, the schemas at the destination table.
Okay.
So you don't really have to manage that part either. So you name what that is. And because I'm always struggling to explain is
No,
an ETL, ELT type of thing.
it's okay. It's okay. Different people have different terminology and definition. And as you mentioned, why I'm putting it upfront is just for the audience because you are running on Spark. When you are in Spark, you normally pull it and then transform it, put it
Correct.
somewhere in data frames, and then throw it. Okay, let me go back like few years back, like around 9 years, when you say this Spark 15, right? So yeah, this Hadoop came in like 14, 15. That is where it become very famous and famous in a sense. Hey, we have a Spark engine. You can pull everything into memory and do it and then throw it, right? And I think that is where you guys got an idea that why to use any database or this and that. You can have multi-nodes, bring all memories into one place because Spark can pull in all the memories of all the nodes and process it. So that's great. Okay. So okay, let me also throw this high level question, right? Just for our audience, how you compare yourself with other tools in the market versus yours? Because we have Informatica, we have SSIS, we have ADF, we have many tools there and very expensive, by the way, right? How you compare yourself? Then I will go into cloud and on premises later.
Of course. So to be absolutely brutally honest, we liked Informatica, right? We like what they offer. They have an extensive capability for managing and processing the data. The
Mm.
drawbacks are, like you said, it's very expensive, and you also need coding data engineers to do this whole, they use Spark underneath as well, to do it properly, right? So big organizations can afford it, and it's being used by a lot of enterprises, even for the last 20 years at least. What we wanted to do is sort of democratize that capability, but bring it to people that anybody could use it,
Mm.
right? You've got the power of that data processing, the manipulation of data, freedom of designing your architecture the way you need it. but without the complexity of coding and also all the expense that needs to go into doing it just by buying the licenses, right? So that's where we differentiate. We also abstracted, like I said, abstracted the Spark coding from it, right? So now you don't need to have a Apache Spark data expert to work with Apache Spark. And that is a game changer because you are now lowering the threshold to use the powerful technologies around, streaming, chain aggregations, pipeline management, cluster management, memory management, all that stuff that happens with Spark underneath. You don't need a person that knows that inside out for, say, 5, 10 years experience. But you have a general data engineer who knows Python, SQL, knows architectural concepts, understands what data pipelines need to look like, and can build these integrations, but doesn't need to know Spark. So you're putting a very powerful tool into the hands of more people, and that allows a lot more adoption across the data estate, so to speak.
Okay, so as you, my next question, you already answered that your tool already also works SQL and Python as well. Right? These
Correct.
two languages, only these two languages, or these two languages you think is good enough to build whole thing?
So the logic was around what are the most commonly used
Hmm.
within the data developer, not to code solutions, but to code business logic, right? So it's slightly different from because they can write in Scala and use Rust and you name it, right?
Hmm.
If you abstract, because in those layers you code the processes that we've automated,
Hmm.
right? So
Hmm.
you abstract that, and what you'll have left with, oh, I need to join that data, right? I need to aggregate it. I need to check for data quality. So you've got a bunch of if-then statements, or you've got Python. So if
Hmm.
you then have, for instance, created applications, or you want to go and make a call out to a Gen AI, for instance, and it set that procedure within your data integration pipeline. Python allows you to do a lot of things. I mean, this is the most flexible language out there. So that's where we kind of settled on these two technologies.
Okay, fair enough. Okay, now let's go to the more difficult questions.
Always with you, Mustafa.
I'm wearing my essay cap again. Now, your solution or a tool actually is an on-prem tool or cloud tool. When I say cloud tool, I'm very specific as a PaaS and SaaS, not IaaS. Infrastructure on a as a service is again an on-prem solution. So
Got it.
what you are?
Yeah, so we're mainly it's a desktop application, right? So it's not a SaaS solution. We don't run it natively in the cloud.
Okay.
Now, that said, you can run it anywhere. So
Hmm.
you can run it on-prem, you can run it locally, you can run it in the cloud. So if you spool up container service virtual machine,
Hmm.
that's all you need to do. So within your infrastructure, we also bring infrastructure to the clients if they don't have a cloud infrastructure. We're happy to set it up for them. And
Okay.
we're partners with Google, Amazon, and Microsoft, obviously, for those reasons. But once you've set up the infrastructure in the cloud, our tool automatically manages the memory, the scaling of it within the given constraints of that container, right? So
Hmm.
um, if you throw in a large compute cores, many cores, then obviously you can process a whole lot of data. It will be a lot more expensive for you because we will try to optimize within the available infrastructure. So you can, but the way we've optimized the code, so you can run large jobs on the modest machines to save cost,
Hmm.
obviously. We've seen over 1 million transactions per second quite easily without even trying
Yeah,
on
that is very fast.
yeah,
Yeah.
yeah,
So when you mention, so clearly it's an on-prem solution, and when we say on-prem, it's not only on-prem servers. We are talking about IaaS. We can have VMs and Kubernetes over there.
Yeah.
So when you say that, it becomes a little bit difficult for customer, right? Because then I have to build my own team to deploy your this is scale up, scale out concept. So you in your company, do you have those expertise that I say, hey, please come over and build this whole thing for me? Can.
Yes. Yeah.
Okay.
We do that. We've done that for clients using their data centers. So they've already paid for the machines. We just set it up for them and the management around that. We've done the Azure, we've done EMR, we've done all of these things. Yes. But often the customers would already have some kind of cloud or a data center running.
Yep.
So their DevOps generally don't want us anywhere near it because of, security issues, and then just in general, they like control over it. So they'll allow us to do an install within the specified machine that is agreed by the project, and then they can run it with it. So it depends again on the type of client. So
Okay.
so far we've encountered most of the customers that we work with are adept at data. So they handle a lot of the things themselves.
Okay.
Not just because they don't want us to do it, as in we can offer it, but they say, no, this is our remit. We do it.
Okay. 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 One more difficult question coming towards you. So when you implement, you have, let's say, 100 jobs, 10 jobs for one project, 10 jobs for another project, 10 jobs for another project, and so on. And each job is consuming its own infrastructure at backend. For example, you end up spinning 50 odd nodes in your Kubernetes or containers, and each job is spinning up and down and all those kind of stuff. Do we have a tagging concept in your tool that this job is consuming these number of VMs and this is the cost?
No. So we focus only on the actual physical movement and handling of data.
Okay.
Right? This is where we combine our solutions with, say, if you needed data orchestration, we'll do with something like Airflow or Orchestra, right? If you wanted to then do FinOps, then the customer either has their own, or we can recommend partners around if they want to monitor what their exact cost of each job is. Now, we haven't built those because our expertise is just purely in doing the integration.
Fair enough.
Yeah.
Why I'm asking is because big organizations, what happens within one tool, they create hundreds of jobs for each project and each LOB or each department, but then they need a cost recovery. So what I am understanding here is because this is a very small tool, lightweight tool, if 5 projects need to build their pipelines, we better create 5 instances separately and everyone runs their own.
Yeah, if they're distinct, if there is no interaction between the data that they're going to be using for each other, or you can do the data exchange, for instance, you have it somewhere, say in the warehouse where different projects can pull some of the, so you don't need to process the same data twice. You can process it once in one job, have it somewhere ready for people to consume. Other projects can then just piggyback off that particular ready-made data and then add their additional integrations as they need. That way you sort of have a network effect and also minimize your computes.
Yeah. Because what I'm thinking is because nowadays warehousing and all those analytics, people talk about or think about Databricks and Snowflake. These are getting very famous, right? So these are two ETL tools as well as serving tools, right?
That's right.
When you talk about ETL tools, they are not very friendly. They have their own notebooks. You have to go and write down the codes. So that is where your tool comes in, that your tool can be used. And by the way, your tool can read from anywhere based on JDBC connectors, or you have your own native drivers to connect.
No, so we do JDBC, ODBC, flat files, buses, APIs, right? So you got data somewhere, we'll get it. We read it from mainframes, so that's no problem. Yeah,
Okay.
and you're absolutely right. Because of the integration tools are not always very friendly, user friendly, or have limited functionality, we partner with Snowflake to do exactly that. So if people have more real-time streaming use cases or complex use cases where they just want to have automation rather than manual handling of the data, we can pull it into Snowflake reliably, and then they can do their work and serve the data out of Snowflake later.
Okay, this is something very exciting you have brought it in, and I want to spend a little bit more time into it. That when you partner with Snowflake, because
Hmm,
Snowflake has its own ecosystem, right?
correct.
We are not going into a AI and ML. Let's stay at a warehousing. So they do the all processing and serving as well. And when you say you partner with Snowflake, where do you sit? You only bring one to one and load it over there, or after loading, you do processing as well?
No, so I mean, the idea, like you said, Snowflake does the processing, right? They're very efficient in that. If you do crazy queries, it'll be expensive.
Hmm.
But what we are doing is also not just lift and shift, right? Because you've got other tools to do that. What we do is we move the data into Snowflake in as close a state for consumption as it's possible, right?
Hmm.
So we will do the quality checks, we'll do the cleaning of data, right? We will do the transformations, aggregations of different data sources before they get into Snowflake. So
Ah,
once the data is in Snowflake,
okay.
you can do BI models on it. So you can still do aggregations and you'll do your experimentations there, but you don't need to do the hardcore management of data. So it lowers your Snowflake cost as well.
Okay. I'll go a little bit further into, right? I'm going
Hmm.
to create this whole gift. So we have a landing area, we
Yeah,
have staging area, then we have transformed area,
yeah,
right? So landing is always one to one. Staging is somewhere we do a lot of standardization. Multiple date formats are coming. We convert into one date format. Null values are coming. We put some static value there. Special characters are coming. We remove special character. If the data is digits, but it is coming as a data type of string, we convert into that. So all those things we do, or we need a CDC, we do CDC at that level. So you are saying from source to landing and up to this staging or slash bronze, which medallion says, this whole piece you do, and post this Snowflake do. Is that what you're saying?
yeah. So we'll do the staging. So you don't need the staging layer. That's why I want to make
You
that
go up
clear.
to level of staging you do.
Correct. You do all the staging in motion. So
Okay.
all the things you've just described, we do it in motion. You don't have to, but we do it because that's the capability we offer. So by the time you are in Snowflake, for
Huh?
instance, right, you don't need the bronze layer. Obviously, it's different there, but you know what I mean,
Yeah, yeah.
right? So then you're suddenly, okay, well, I'm taking out a whole layer of complexity where somebody would use additional tools, for instance, or manpower to process clean that data. Why is it in this format? Why do I have nulls, right?
Hmm.
This way, if the data is null and you got a rule around what to do with nulls, it
Hmm.
will automatically process that, right? It will also give you full data lineage around
Hmm.
per record. So you'll know why it's not null, where did it come from, when it was generated, by which source exactly, and then what time, right? So then you can trace exactly, oh, did my source system go down? Or was the sensor faulty? Or was that person typing, phone number into bank account number instead?
Hmm.
So you can kind of straight away trace where your errors are. Once you in sort of we kind of quarantine bad data into a error data table, and then you can just by exception look through just why this data is bad, rather than going through the entire data set. So we do all that pre-cleaning, right? So by the time you are in the warehouse, you don't have to spend as many hours.
Yeah, so see, then the
Cleaning.
question comes, why can't, because see, when the source data comes, yes, you are right. Sometimes source data comes via API, sometimes those come via DB, sometimes those come as a flat file, right?
All right.
Right. All these three format comes and they all drop into a landing area, which is nothing more than object storage.
Yeah.
So what you're saying is your tool sits here, it can pull all three and throw into landing area. Then you don't need to read landing and load into staging. You can land it here as well, and you can do processing itself and throw it directly into staging area. You don't
Yeah.
have
But
to stop it.
for us, the landing area is a data frame, right? So you will land it into memory. So there's no physical landing space for processing. So then you process the data in memory.
Uh,
When you're happy with it, you can then persist, right? And as you persist the data, you clear out the memory.
okay,
So you
another
can do that at
question.
one record at a time. You can do it in batches,
Okay,
whatever, right?
now we are
But
going
to
to.
do yeah, go for it. But I guess what I'm trying to say is you don't need to land it. You do the processing and in motion. So your staging layer is in memory. You see what I mean?
Okay,
Yeah.
but then I will lose the originality of the data which is coming from source. I need a history over there so I can
Correct.
reload it. After 1 week, I need to patch something. I don't have to go to source. I have a landing area. So if my landing area is sitting in your memory, are you saying you want me to persist the memory for life or for retention of whatever?
No, so you will define how long you define that window, how long you want that data to sit in memory, right? If you need a week's worth of memory, do you really need to keep that in active compute, right?
I
You
understand
will
what.
probably persist that data somewhere where you can come back a week later, 2 weeks later, a year later, and then you can you can work on that. So nothing is stopping you to get the data from the source and then persist it somewhere else, right? For your post-processing, right? So you can still take raw data as you want and put it there. But
Okay,
what we're saying is you can do that and do the processing of it as well. So you can have two snapshots of what your data looks like, the raw data and the processed data, right?
Mhm.
So you never lose any records.
Okay, so let me make it more easy for people. So I and you understand. So what happens, at least a very good approach. We still
Yeah,
cannot get rid of landing. So but first of all, when we talk about landing can host n number of things. Landing can host tabular format, which can be CSVs or any format or KXYZ. Landing can host unstructured and semi-structured as well. So,
correct.
but we are talking about right now structure because your data frame can take only structure. Well, it can take semi-structure as well. So,
Yes,
semi and structure we are only talking about just for our audience. Secondly, we are saying when structure and semi-structure is coming, it is always coming into a format, right? It is already serialized. So, we can have it in landing. This is a one hop. And when we read from landing and load it into staging, that's a separate hop.
mm,
So when we read from source, it goes into a memory and go into landing. Then we read from landing and take it on a memory and then write into staging. So there's two hops. So what you are doing is you are taking care of that problem statement is you don't
yeah,
need an hop. You take it
correct.
into the memory. Yes, you can throw into a landing, but you don't need to read from the landing. You keep it into the memory till the time you process it and store. So now I understand. Now it makes
Yeah,
sense. It
that's it.
clearly makes sense, but there is
Yeah,
another question over there. If you keep into the memory, as long as you keep in the memory, your VM is running. If you are on premises, real time on premises, which is means your hardcore data center servers, then no cost. But if you are in IaaS, there is a cost over there. Am I right?
correct. So what you wouldn't do is you wouldn't run a giant memory store cluster for, say, streaming data, right?
Mhm.
Because you constantly generate records, thousands of them per hour, or however many.
Mhm.
Why would you want to store it for so long in memory, right? You will process it, you'll enrich it, you'll serve it. It's real-time streaming data, it's fresh. You want to consume it as it appears, because that's the whole point of the real-time stream, right? You want to know what's happening
Streaming, I
now.
don't need. Streaming, I don't
Exactly.
need. Transactional, I don't need. The bigger piece
Yes,
will be master and reference data, because
correct.
master
But
and
that's static
reference,
data.
that's
That's
static data. Yes,
static data, correct.
yes.
And the static data, so you have two choices to do it, right? You can pull that data out only as and when you need it. So you don't need to keep it in memory constantly, right? So if
Mm-hmm.
your lookup table is petabytes big, I mean, I don't know why would you ever have a petabyte
Never.
big lookup table, right? But generally, they're much smaller than that. But say you had, you will only pull that reference data when your new streaming data, for instance, coming through, or your batch data, right?
Mm-hmm.
This is at the point where you will combine the two, enrich one with the other, and then you persist and you clear out the data frame. So you don't necessarily have that constantly full maxed VM running, waiting or keeping the data that's not needed in memory.
No,
You're
no,
constantly pushing it
I can
out.
make it more easy for you, because as we are not doing any transformation from
Mm,
source up to staging,
right.
there is no need for lookups. There is no transformation is happening. So you don't
Correct.
need to persist anything. You do persist master and reference data when you need to look up. But here we are
Correct.
not doing any transformation. With Snowflake flavor, it's all one-to-one and data cleansing.
Yeah.
So that is there. So now what you're saying is, when you are doing this, so we are not talking about data center on-prem. Now we are talking about cloud on-prem, which is IaaS. You pull from source, you persist in the memory, and then you process and throw in, do a DQ, whatever cleansing,
Yeah.
and throw into staging. And VM is running. You are saying you will build such kind of containers and VMs upscale, downscale,
Yeah.
that the moment it is running, it will only run, then it shut down automatically. Is it?
Correct. And this is what our software manages behind the scenes.
Oh, okay.
That's where this is the complexity we've abstracted from manual management of clusters.
Okay.
Exactly that.
Okay. Okay.
Yes.
Good, good, good.
Yeah.
So, one more thing, I think I can try to justify your tool, which Snowflake guys friend will not be happy with me, because when you run a Snowflake or Databricks in memory, what is happening? Two things have two kind of cost comes in. One is VM cost. Second, if you talk about Databricks DBU cost, or if you talk about
Yeah.
Snowflake, their own, I don't know what they call it. DBU
Yeah.
cost is Databricks. I don't know what Snowflake calls. So that two cost comes in. So
Yeah.
here, if they used your tool up at least up to bronze/staging, you're
Yeah.
only paying VM cost. You are not paying per node DBU cost or Snowflake cost.
Correct. That's
Only
correct.
your job cost. And what is the
Correct.
cost of that job compared to
So
Snowflake?
so we, because we're not the SaaS platform,
Hmm.
I don't force you to use my compute,
Hmm.
right? It's your infrastructure. So whatever rates you're paying right now for your compute, that's all your cost. I am bringing you a capability, a tool to run on that infrastructure efficiently. So first of all, you don't incur ridiculous costs. And second, I don't make any money out of that. So it's your, whereas if you run SaaS tools, they charge you for the privilege of
Yeah.
running their
Yeah.
infrastructure. So
Yeah.
that's sort of how we come in.
Okay. So you're saying there is no cost of running your job. You will, okay. Okay. Let's not take the numbers amount, but you tell me, what is your licensing model? Is a user-based license, core-based license, RAM-based license, is transactional-based license? Which kind of license your tool we have to pay?
So we have simple structure. We charge per data pipeline essentially, right?
Oh,
And your
per
data
pipeline.
pipeline could be as simple as a single source, however many transforms, data cleaning steps you need, and a single repository.
Hmm.
Or you can have multiple data sources, multiple transformations, and multiple places you persisted in. So it
Okay.
depends on what you're doing, right? So if your infrastructure supports heavy number crunching, big data, you're coming, terabytes, petabytes of data, and you throw in, I don't know, 8-core machine on it, right? then you can have as complicated pipeline as you need to be. Or if you're doing, like you said, I got multiple departments, multiple disparate data sources, then you'll just have multiple data pipelines. So a small business can get away with one or two, three, four, maybe depending
Oh,
how
you don't
complex their
limit number
operations
of
are.
jobs. Yeah.
And enterprises will pay for more because they have a more complex architecture.
Okay. Okay. So you are not restricting a customer to buy, hey, you have to buy 10 jobs minimum. No. Is it?
No, no. We don't charge for volume of data that goes through us. We
Okay.
don't charge for a number of people using our tool,
Okay.
um, purely per deployed data pipeline, right? So if you're doing development work, we've got a free developer edition, download it on the laptop and go and play with it, right? Full functionality, except you won't be able to run it on VMs or uh, clusters. So so when you develop, you can spend 6 months playing around, doing all kinds of stuff, testing, whatever you need to do. Structure your entire enterprise around that if you need to. Only when you start doing production deployments, then we will
Production
charge.
or UAT as well.
No, UAT, well, I mean, UAT assumes you're going into production, right? So,
Yes.
but we will charge you post UAT. So you've deployed it, it works, you're happy with it, and that's
Okay.
when we charge.
That's a good piece. So you're saying till the time we are doing R&D, XYZ, you don't charge anything. The only
No,
time we go to productionize, then you start
correct.
charging. And per user, sorry, per job, and you don't mind, I end up creating my whole ecosystem in one job. You don't care.
I don't care.
Okay,
That's
that's
that
good.
that's Yeah, it's absolutely your business how you want to run your structure. But what we generally recommend, right? Not just because we want to make more money out of it. No, it's in terms of ease of management, in terms of ease of tracing errors through the system, right? If you have a very complex data integration pipeline with, I don't know, 10 transformation jobs, or you have a SQL of 10 pages long, right? It's probably going to be difficult for you to, if you ever need to change logic or trace anything, to go through that. So you want to split it into nodes as simple as possible, maybe one step at a time, so you can easier, debug it,
It's
patch
a
it,
give and
whatever.
take, right? You want
Correct.
very easy tool, pay high. If you want
Correct.
cheaper tool,
Yeah, it becomes a bit more complicated.
yeah,
Correct.
operational versus cost, which is fair enough.
That's it.
Okay, now I will go because as you are a new tool, right? I will ask some other questions about how it do the logging. Okay, let's go
Yeah,
step by step. Which kind of logging you do? Anything fails? Can I go
yeah,
up to the transaction level and find out what happened, where happened?
right. So, very good question, by the way. We've got full Spark logging, right? So whatever Spark is producing behind the scenes when your pipeline runs,
Hmm.
right? Spark creates a lot of very detailed logs
Yeah.
behind what it does, right? How it allocates memory, what processing steps it's doing. All of that log is available in JSON format once it's done, right? So you can have any tool that consumes JSON, you can easily translate that. The second part is we do full end-to-end lineage of the data, right? So every time we ingest the data, we add the additional fields to it behind the scenes,
Okay.
right? And these would be timestamps, these would be keys around that, there will be other identifiers for our internal kind of purposes, right? Each one of them is obviously traceable and logged. And as your data flows through each node of the data pipeline, we keep record of it. Okay, it's done
Sorry,
ingest.
sorry. Question
Yeah,
here, very specific. I'll
yeah.
say it. What you're talking about is metadata. Lineage is if you have 10 hops, it'll tell you which data, which column come from where. Are you talking about metadata? You're talking about lineage.
No, so both. So one is the metadata, right? So each way as it went through. But the other one you asked about logging, right? So what I'm saying is through these steps, and each node will have its own log. Is
Hmm.
this is ingest? This is when it happened. This is what happened to that. What
Hmm.
is the logic behind it? What's kind of data source? So you got a metadata in there as well as what happened to it.
Okay,
And
okay.
through the detailed data record lineage, you can trace each record of the data as well through that system to see what happened to it in that transform number 77, right?
Mhm.
Not only visually through DAG, but also it'll tell you exactly what happened to
I was
that.
about to
If
ask
there's
this.
an error, it'll kick it
Yeah,
out.
I was
Yeah.
about to ask, do you have any visual screen to show that?
No. I think a simple answer is no. So we create the logs, we don't visualize them. Now it's one of the nice things that we want to add later on to make it simpler for developers. But at the moment, because there's so many tools around that, it's almost like sometimes
I was
feels,
about to ask this. Do you
yeah.
propose any tool? Have you implemented any tool which has pulled your logs and showed the lineage?
Uh, yes, not ourselves, but our clients did.
Yes.
So because they always want to see the logs,
I was
right?
about to say
So
that now because I'm
yeah.
a customer to see somewhere. So
Yeah.
you're saying it has been implemented somewhere, right?
Um, we visually do not say it. With the customers, they use the third-party tool to do it, right? And it's literally looking up JSONs. So once you've got a JSON ingest, then they can
Okay.
read that.
Okay. Fair enough.
Yeah.
So there are one or two reference customers which you are saying, sorry, becoming so excited, right?
Yeah,
So,
yeah, yeah.
so you're saying there is a customer, at least one customer who has used third-party tool to read your JSON
Correct.
and
Correct.
created a lineage. There is,
Yeah,
right?
and they will say I got to make another one just because we're talking about these things. We also don't have a scheduler in, right?
Okay.
So
That
if
would be
you're
nice.
orchestrating multiple pipelines, you want to use a third party tool. A lot of customers use Airflow, but there's I mean, it's a great product called Orchestra that does these things even more, much more easily.
Oh,
So
okay. Yeah.
yeah,
Okay.
so there's
Um,
there are ways to do it.
Okay. So my next question. So okay, okay. So you have covered that you are capturing every kind of metadata.
Yeah,
You are capturing all lineage.
yeah,
What about high availability and backups? How you manage that? If your job crashed,
correct.
memory went down because
Yeah.
it's all in memory, it can happen. Someone restarted the VM. What happens?
So we have this concept of checkpointing,
Okay.
right? Yeah. And what happens is when you persist the data, right? So you've cleared up your data frames, right? You clear up your memory. We take a snapshot of that, right? What was the last transaction that was processed, right? When? So if your source system goes down, IOblend will just sit and wait idly until the system comes back, right? It will send an alert. Look, your source is down, so the devs are aware of it. But when the system is brought back online, say a day later, 2 days later, it doesn't matter, right? And your source system was maybe 1 out of 5. So the other 4 kept processing the data as they were pushing through. But you're now missing a chunk of your data, right? You don't have any kind of totals within your destination.
Mhm.
So when the original system comes back online, what IOblend will do is it will, through that checkpoint, it will know what the rest record read
Okay.
was. And
Okay.
they will pick up the missing data from the point when it went down, reprocess all of the totals forward, right? Now, obviously, you've got the original data, which is only, say, 4 data sources. Then you'll have a new table that will have all 5 recomputed. So you have a comparison of what was really happening. And here's the backfill of your data. We'll match all the totals, recompute and stuff. And if you're pushing your dashboard, then obviously your totals will recompute out there as well. So
Okay.
all of that we'll do automatically, right? So you really don't need to worry about systems going down. I mean, you need to worry about systems going down, but not necessarily around, am I going to lose my data?
So it
So,
means you have introduced this queuing capability as well, like Kafka do. Kafka also keep this track of last processed
yeah, yeah, yeah,
transaction, right?
absolutely. Yeah,
Same,
yeah. And
same
we'll
thing.
do, and we will regress, right? So that, which means we'll go back in time. So we time travel, pick up the data that wasn't there. Absolutely, yeah.
Okay.
Well, this is what's when you construct good quality real-time data pipelines. All of these features, ideally, you have to code, right? Otherwise, you won't have a data streaming pipeline because, like you said, well, what if this happens? What if that happens? Somebody needs to put those features in. Very few tools do it really well out there,
Yeah, yeah,
right?
I'm very happy
Yeah.
that you're doing it. So I will bring Kafka. Are you saying we don't need Kafka anymore?
Well, let's put it this way, right? So we connect to Kafka, right?
Kafka.
Correct, yes. So this is a message broker, right? So you get the just literally the flow, right? Do you need it? Yeah, some companies use it, right? Because you can pull the data out of Kafka, which they will do the fast, high scale
Yeah.
streaming data at scale. Leave that there. If it works, I mean, okay, it's there, additional layer to manage, but we'll put the data out of Kafka and then we'll do processing of it and transformations and so on. But if you had a raw source, say like a SCADA device, right, or ESB bus that you could connect to, you can use IOblend as raw without Kafka. Absolutely.
So,
And
so
it'll do, yeah.
I think I will not be diplomatic. I will say that if we have this tool, your tool,
Hmm.
actually I don't need Kafka because Kafka I need to manage another infrastructure. And if it is Microsoft Kafka flavor or some other Kafka flavor, I have to pay their license fee. So by right, you're saying we don't need that flavor, that queuing tool. I can directly connect to you. Correct?
Yes, you can, absolutely. But
Okay.
the
Mhm.
the the word the consideration here is if you already built that in, you need to do the total ownership cost of pulling it out, unpicking it, decommissioning it, taking your resources out, redeploying it on because you're gonna rebuild the connections, right?
I have a limitation over there actually. Over
Yeah.
there, I cannot process more than one MB file.
Well, there you go. So if it's a bottleneck, then it's a different use case for you.
Yeah.
Exactly.
So those limitations
Correct.
are there actually. So if for you,
Correct.
there is no limitation, right? I
No,
can.
again, it's whatever your infrastructure supports. That's your only limitation is your physical box, essentially.
Okay, okay. That makes sense. That makes sense. Okay, okay.
I got you confounded, my friend, didn't I? No
No,
worries, it's the end of the week.
this is what our podcast is all about. We go technical and we make
Yeah,
sure my aim is my viewer is a solution architect and they really understand how to implement this thing, right?
yeah,
Okay.
yeah,
Okay. So you guys are on all clouds XYZ and you can connect to multiple source
yeah, yeah,
systems.
yeah,
You
yeah,
can do real time, you can do
yeah.
batch processing, you can do so you mentioned that orchestration tool is something you have to bring your own and then run your jobs. Okay, that you also covered. Governance and compliance, I think you have also covered that with your metadata and data lineage end to end, these things are covered, correct?
What the
Yeah.
beauty of it, because you can connect simultaneously
Hmm.
to all the clouds. As say, for instance, two of them are data sources, but the third one is a destination. So
Hmm.
you can do that. You can at the same time pull data from on-prem or your data centers, whatever. You can run compute either in the cloud, you can run it in the data center. So if you think about the architecturally, right, you now have sort of a multi-cloud approach. So if you wanted to run your enterprise
Hmm.
on well, if you're if one is squeezing you for costs, for instance, you can easily switch clouds rather than being locked into one
Yeah.
because your underlying integration does not depend on one particular technology.
That would be, I would be asking, I was about to ask. So you are also cloud agnostic tool, right? Your
Correct.
tool can run anywhere. You build it
Yeah,
here, tomorrow you have a decision to go over there, copy paste over there, you take
that's
everything.
it. Yeah.
Yeah. Okay, what about okay, I think let me throw this question. So if you're using Spark,
Mm,
can I say that all BI tools can directly consume from your data frame which you create?
correct. If they can access well, we can have an API as an output. We can have, you know, dump a CSV file if they want to ingest it from a folder somewhere, by all means, right? So you can have real-time streaming, say Power BI dashboard. Data
Mm-hmm.
will flow in, and I mean, I don't really know a lot of use cases where you need a real-time data BI Power BI dashboard, for instance, unless you're measuring something like sensors, you know, like how is my
Yeah.
real-time dashboards. So where you would use that is usually live data, say from sensors,
Yeah.
you know, reading the data as it's coming through. Financial instruments, something like a ticker price, right? Something that's being traded
Mm.
real time live. Transactions from online shopping, for instance, right? Things like that you want to monitor in real time. But generally, dashboards are static, right? You might refresh them once a day, once a week, you know, your financial snapshots, that kind of thing.
Correct, correct.
So,
So actually, real time is not only for dashboard. Sometimes what happens, they have their own application,
hmm,
and they say, hey, we don't want to build an ecosystem of real time. Hey, IT, do you already have an ecosystem which can process my census data? So you can
hmm,
process it. It comes to your Spark data frames, and we throw into their application.
yeah,
You throw into Power BI dashboard. You are absolutely right. 90% of times
yeah.
real-time dashboarding does not make sense because it's going like this, doesn't make sense.
Exactly. You can't make any decisions. Exactly. Yeah, it doesn't make sense. It's okay in like operational settings,
Hmm.
but generally for planning commercial decisions,
Yeah, yeah.
you wouldn't use that.
Okay. No, man, it's okay. It's okay. So, what about actually is a time check? We are already 60 minutes there. I think I can take you 5 minutes more if you don't mind. I hope you
Yeah,
have.
go for it. Of course.
Yeah. So how about your, because you're again, I'm asking some blunt questions because
Hmm.
you're a new tool. People will ask these questions. If you go into an organization, something my organization, they'll say, what's your 5 year plan? If I bring in, I create pipelines on it, tomorrow you
Yeah.
go, then what will happen to me?
No, so I mean, obviously, we're sort of a growing company. We just celebrated 5 year anniversary, so we've been around for a while. We have a journey to go to. So there are a lot of things around we want to optimize um, around UI UX, right? Make it a lot easier to more user friendly in the sense. So it was designed by data engineers for data engineers, right? So I like to see a little bit more, user friendliness around that, but also helpful features like prompts automation, helpful tips that might pop up here and there. Have you considered this? What about this? And eventually, of course, bring some AI capabilities into it as well to make even easier the way to manage your data pipeline, or like read the logs, for instance. You can just quickly find so rather than you looking through the logs, you'll just summarize and say, look, actually, this is your problem there.
Yeah. Okay. So now I will come to our conclusion questions on a data integration because you guys again are an inventor. So you have created a tool, right?
Mm.
So you guys had a vision. So that is why you have created. So for our audience, right, where do you see this data integration going in next few years?
That is a very good question, right? I mean, we had that debate with our CTO because he's the guy who really sees the future. And over time, right, you will have AI doing these things, right, end to end.
Yes.
Now, it's nowhere near it yet, but logically, this is where the industry will end up,
Yeah.
right? It would AI will solve a lot of things for us, right? One day. I mean, I don't know if it's next 5 years or 10 or 15, right? But that's the direction. So what happens then? Like I always come up with a question, say, look, okay, well, so if we rely on AI to do all of these things for us, do the coding, the management of everything, right? How do we become experts? Like, because somebody created these things behind the scenes. What's the value add from the ground up? So if something goes bad down, AI just goes rogue or something, right? No one would even know how to fix it because no one has the skills anymore.
Yeah,
Now
I
it's been
I don't remember my wife's mobile number because it's already recorded.
Same thing. I have no idea. I always have to look it up, right? Okay, but that's maybe not the world-ending kind of thing, right? But you see what I mean? Some people say, look, it's a horse cart versus car, right? Yeah, okay, that's fine. But we still, as humans, can build a horse cart if we need to, right?
Yeah.
Can we build a data integration layer 15 years after AI has been doing it for you? I mean, not a hobby. I don't know. I mean, literally, if you never need to learn Python, if you never even have to look what SQL looks like, right? Because you're used to just asking. It's like, hey, give me a summary for my financial snapshot. You don't even know what the data structure is underneath,
Yeah.
right?
Yeah. So what I foresee is, see how I look AI, right? I say, hey, while talking, I'll say, I want to connect with source system. So AI will ask me, which source system? I'll
Yeah,
say, Oracle source system. It'll ask me what is the IP and user credentials. I put it
yeah,
user it'll go and connect automatic. Then it'll ask me, it's a pull or push. I'll say, of course, pull because I'm creating over here. It's a
yeah,
real time, it's a batch. So I keep telling that, and this thing will keep doing that.
yes,
Okay. So the only thing it won't be, I think, will be able to do it is to create semantic layer because
yeah.
semantic layer is something which is very near to business. You can tell it, but you need human intervention over there to understand
Well,
how.
that's today. But think about 10, 15, 20 years from now, right? You've got something like Jarvis from the Iron Man movies, right? And then suddenly, can it not? I mean, but you just think really far ahead. But everything you just said, actually, about do you really need AI for what you just asked to do it? Because all you've done is a logical tree. I want this
You
as a
need if
drop-down
else.
menu,
You need
fully linear solution.
yeah, you need all if else. We
Correct.
have all those.
Exactly. So technically, you don't really need AI because it might get confused. Whereas with the if thens here in this particular use case, you'll not have an error because there's no confusion there. You just pointed it directly to what needs to be done.
Yeah, see, I also see I'm always an advocate that AI will not kill the jobs.
No.
AI will open more doors, more visions, more ways to do it.
Whatever it is that is happening out there, people realize that they actually need data, they need more data,
Oh,
and
that's
they
a good
need to
part.
be able to process and integrate that data to make decisions. And that keeps me going forward because
Yeah. So see,
no,
till this time, we are just winding it. My apologies, right? So
no worries.
this time, I'm in data industry all 20 years. People did not care about data. Now people knows data is very important. But
Exactly.
unfortunately, people are still debating whether we need data model or we don't need data model.
That's true.
You know,
That
that,
is so
that
true.
debate is
Yes.
still there. That debate should not be there. Take a decision. Either you need, you don't need. If you don't need, then your consumption power, your memory power will increase because you have to do everything on the
Yeah,
fly.
that's
If
it.
you need, then take a decision to need and then move forward now. Right now we are stuck Snowflake, Star Schema, 3NF, Data Vault, Data Lake, Lake House,
Yeah.
you name it. So
Yeah.
many patterns to do the same thing.
Correct. But again, it's a sort of like, think about it. The whole industry is experimenting.
Yes.
What will stick? Now we've got iceberg, right? So that's a whole new thing coming up.
Yeah.
So it's all around finding that sort of standardized way, but the efficient way, the ones that's easy to use. I mean, we've been with Excel for how many years, right?
You can't beat Excel.
Yeah, people tried to replace Excel so many times, right? But it's still there. If people love it. I love Excel,
I tell
right?
you no. Notepad, Paint.
Yeah.
You, can you replace that? You can't replace that.
No, 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 of course not. But there you go. But people will not never end trying, right? They will always attempt to do things. So I will welcome for it. Lots of different technologies, experimentation. That's what keeps the whole industry dynamic and exciting. This is why tech is growing and like, you know, I you don't like if it becomes boring, static, I don't want to even do it because it's like
Yeah,
it's the
yeah.
same thing, right? So, but this is what I like. So let them experiment, let them build different things, because one day we'll find something that is works for everyone.
Okay, awesome. I think again, thank you so much, Val, for taking out time for us. It was a very good tool discussion, I would say. And
Thank
I'm
you.
sure people will come to know about your tool, and this podcast will really help us to take a decision whether to use. I'm sure we have built some use cases, not for multinational companies, at least for SME and small companies who will be
Yeah,
really looking into it, especially those who are using Snowflake as well and Databricks as
exactly,
well. They can build
exactly,
their pipeline from source to bronze slash staging to save cost. They can do that. So I
exactly.
think we have done a good job.
And
You have done a great job to explain me all those
oh
stuff.
no, thank you. You've been a really gracious host, but also for our viewers, look, if you guys are interested to explore what else we can do, by all means, always reach out. You can find me on LinkedIn. You can visit our website, send me an email directly, and I'll happy even just chat with you. See if if you got any kind of issues with data integration, by all means, pick my brain.
Awesome. Thank you so much. Have a nice rest of the day. Pleasure and take care. Take care.
Cheers, my friend. Cheers.
Bye.
Bye.
Bye.